Welcome back. Today we're going to talk about Chapter 12, Section 4, which is measures of dispersion. Dispersion refers to spread, so how spread out our data is. It's used to measure the variability of the data. So variability, think of variables. It's how the data is changing. So a lot of times we're interested in the spread, like what happens from the lowest value to the highest value, and how do the data vary about the mean. So remember in the last section we talked about the mean, which is just the average. And to find the average, it's the sample average that we're worried about. It's the sum of all the values divided by the total number of numbers. So the two measures of dispersion that we're going to discuss in this section are the range and the standard deviation. The range is just the highest value or the maximum minus the lowest value, which is the minimum. So it's max minus min. The range is helpful to know how spread out the data is, but what's a disadvantage of the range is that we don't know what's going on in between the lowest and highest values. So when we want to look at the variability within, we're going to look at the standard deviation. And before we talk about standard deviation, let's talk a little bit more about the range. It's the difference between the highest and lowest values in a set of data, and it indicates the total spread of the data. So that's something important to remember about the range. So if we take a look at the amount of calories in a slice of cheese pizza from 9 different pizza parlors that's given, determine the range of these data. So what we need to determine first is our maximum value, or the highest value. And here the highest value looks like it's 320. And our minimum value, or the lowest, looks like it is 234. So to find the range, all we're going to do is subtract max minus min. And when you do that, you get the number 86. So 86 would represent a large range of values between the lowest and the highest. But how do those values vary according to the mean? So we want to look at the standard deviation, and that measures how much data differ from the mean. So I like to think of standard deviation as, on average, a number's distance from the mean. There's 2 letters to symbolize standard deviation, just like there's 2 letters for average. When we're dealing with a population average, we use the Greek symbol mu. When we're dealing with a sample average, we use x bar. So when we're dealing with standard deviation, we're talking about on average a number's distance from the mean. There's a population standard deviation and a sample standard deviation. So when we're calculating the population standard deviation, we use this symbol here, which is the Greek symbol sigma. It's lowercase sigma. And in our book, though, the numbers that we're given are always going to be a sample. So we're going to use the letter S for standard deviation. So one thing to remember is that the larger the variability of the data about the mean, the larger the standard deviation. So without any knowledge of even how to calculate the standard deviation, let's take a look at 2 sets of numbers. And I want you to look at these numbers and figure out which has the larger standard deviation and why. So which data set has the numbers changing or varying about the mean more than the other data set. So feel free to pause the video and take an educated guess, and then we'll talk about it. So the first thing I would do to figure out which data set has the larger standard deviation, since it's the variability of the data about the mean, I would want to find the mean. So to find the mean, remember, we're just going to add, like in set number 1, we would add 5 plus 8 plus 9 plus 10 plus 11 plus 12, and then divide by 6, which is the number of numbers that there are. So when you do that, you get your average for data set number 1 is 9.2. And if you find the average for data set number 2, it comes out to be 9.5. So the averages are very, very close. But in which data set are the numbers varying or farther from the mean? If you said data set number 1, you would be correct. Because if you look at your numbers, like let's look at set number 5, think of like a number line where you have the numbers 5, 6, 7, 8, 9, 10, 11, 12. Okay, and let's look at set number 1. So you've got numbers 5, 8, 9, 10, 11, 12. And my average, I'll put in green, is like 9.2, we said. So look at the distance those dots all are from the green dot. Okay, I'm going to slide this down and I'm going to show you what set number 2 looks like now. So here's set number 1. Okay, let's take a look at set number 2. If I do the same thing, it goes from 8 to 11. So we've got I'm going to get rid of this so I have some room here. For set number 2, you've got 8, 9, 9. Okay, so what I'm making is a dot plot. I'm just putting dots above the numbers. When there's more than one of the same, you just stack them. So there's 2 10s, there's an 11, and again, my average I'll put in green. So the average is 9.5. So which data set looks like the dots are further away from the mean? I would have to say data set number 1 has the larger standard deviation. Those data points are further away from the mean. If you look at 5 and look at its distance from the mean compared to 8, which is the lowest value, and its distance from the mean, or 11 and its distance from the mean, it's a lot further away in set number 1 than in set number 2. So set number 1 has the larger standard deviation. And I'm going to put here, the reason is because in set number 2, the data values are farther from the mean. So how do we actually quantify an actual value for the standard deviation? So there's a process. Let's take a look at how we calculate standard deviation. So let's say I want to analyze the dispersion of the data for commute time for students at Valencia College. I'm interested in calculating the standard deviation. It would be very difficult to survey the entire population of all students at Valencia. So what I'm going to do is I'm going to take a random sample. And let's say in our random sample, we have 5 students from class, and I ask how long it takes for them in minutes to commute to Valencia College. And we're going to find the standard deviation of our sample. Okay, so this is how you would do it. And I kind of broke it down into a table so that you can follow the steps. Luckily for us, calculators are great at calculating standard deviation in an instant. But if you needed to calculate it by hand, this is what you would do. So let's say our commute times for our random sample of 5 students is 5 minutes, 15 minutes, 15 minutes, 10 minutes, and then let's say 35 minutes. So the very first step is find the average. And to find the average, we're looking for our sample average. So that's our X bar, right? So that represents our sample average. We take the sum of all of those numbers. So you're going to add 5 plus 15 plus 15 plus 10 plus 35, and then divide by the number of numbers. There's 5 numbers. So if you add all those up, you get 80. And then when you divide by 5, you get the average. So on average, it takes those 5 students 16 minutes to travel to Valencia. After you find the average, step number 2 is to take each of those values and you're going to subtract the mean. So I'm going to take my values here and just rewrite them. And now the mean that you found, you're going to subtract the mean from each of those values. So whatever the mean is, just subtract. And when you subtract, you get 5 minus 16, that gives you negative 11. 15 minus 16, negative 1. 15 minus 16, negative 1. 10 minus 16, negative 6. And 35 minus 16 is 19. Now what we need to do, since we're measuring the deviations away from the mean, it's the distance. Distance can never be negative. So to undo the negatives, we're going to square everything. So you're going to square all of these numbers. And when you square them, it's going to get rid of all the negatives. So negative 11 squared gives us 121. So remember, that just means negative 11 times negative 11. Negative 1 squared is just 1. Negative 6 squared is 36. And 19 squared, or 19 times 19, is 361. And remember, the Greek symbol sigma, capital sigma, is just a summation. It means add all the numbers. So you're going to add all the numbers in that column. So when you add all those up, you get 520. Our next step is to take 520 and divide by n minus 1. So remember, n is just the number in your sample set, which would be 5 sample numbers. So n is just 5. So we're going to divide by 5 minus 1. You're going to take 1 away because you're finding a sample standard deviation. If you were looking for a population standard deviation, you would divide by the number in the population, which would be 5. So that would be if you were looking for the Greek symbol sigma, which is the population standard deviation. We're not doing that. We're finding S, the sample standard deviation. So really, we're just dividing by 4. 520 minus 4, or divided by 4. So 1 less than what's in your sample. And when you do that, you get 130. The last step that you need to do is then take the square root of that number. So when you take the square root of 130, you get 11.4. And the label we use for standard deviation is the same as the label for the data. So the data represented minutes it takes to get to school. So this would be 11.4 minutes. So exactly like what does that mean? It means that on average, how each variable, or each value, we'll call it, differs from the mean. So on average, each of those data points is 11.4 minutes from the mean, typically. So let's build the actual formula. The formula looks kind of scary when we're finished with it, but really all we did was the formula just broken down into steps. So what's the first thing we did? We needed to take all of our values x and subtract the average. And then once we did that, what did we do? We squared everything to make it positive. Then what did we do? We added all of them. So let me move this down. We added all of them. Remember, the Greek symbol sigma is add. So we added all of the squared distances, and then we divided by the population minus 1, and then at the end we took the square root. So that's actually the formula we use for standard deviation. And all I did was just break it down into steps for you. Okay, I would like you to practice now. There's 9 different stocks here from the New York Stock Exchange, and you need to determine the standard deviation of the prices. Okay, so now would be a good time to pause the video and then unpause it when you are ready to figure out how to do this. So the first thing you would want to do is you would want to find the average, right? So to get the average, you're just going to add all the values and divide by the number of numbers. So I'm going to take 17 plus 28 plus all the way up to 104. And then just divide by how many numbers there are. And I think there's 9 numbers there. So when you add all those numbers up and divide by 9, you end up with 51. So that's the average price of the stocks. Okay, the second step, remember, is to take all those values and now subtract the average that we got. So I'm going to take each of those values and subtract the average. Now you're going to take, in step number 3, you're going to take each of these values that you just found and you're going to square all of them. Remember, we're making them positive. You can't have negative distance. So squaring will just remove the negative, and then at the end we take the square root to undo what we did, and it will turn positive. So all I'm doing now is squaring, negative 19 squared, and so on. If you're using a calculator and if you're typing in negative 19 squared, be sure to put parentheses around the negative 19. Otherwise, it's going to square the 19 and then add the negative at the end, and that's wrong. You're squaring a negative 19, not a positive. So be careful. Okay, the next step is to add all of my values. So when you do that, you end up with 5,836. So I'll call this part where we squared everything step 3. And then this part here is step 4. Step 5, you're going to take the sum that you get when you add up the squared deviations. Remember, you're going to divide by the population minus 1. So it's going to be 5836 divided by 8. And that's going to give us 729.5. And then the last step is you're just going to take the square root of that number. And you end up with 27. So $27 is the standard deviation. Okay, that's the end of the video for 12.4. If you have any questions, please let me know. Please also make sure you're working on the homework. Have a great day, everyone.